I don't want to go away from the subject of the Frugal Repairman as abruptly as the last video ended. The reason is there are a few things that earlier in the series I mentioned I would talk about and I never did, and a few other things that I would like to kind of wrap up for people who I'm hoping are inspired by the idea of fixing up nice old radios. By the way, that's the name of a book that you might also look for, although I think it's out of print. But one of the things that I talked about is, as I would talk later, is testing capacitors. Now, we talked about capacitors, and we talked about the paper capacitors that are in this, and in the last, the very end of the last episode, I mentioned that it's my practice to replace the paper capacitors in these old radios with modern plastic film capacitors. But it's not my practice to replace the electrolytics. Rather, it's, now this particular radio, the electrolytics have been replaced, and whoever did it, well, let's just say that if your opinion of someone who covers things with plastic tape is the same as mine, well, let's just leave it there. This is not the way that I would do this. But one of the reasons that people often do it this way is they don't want to go to the expense of buying new old stock capacitors. Now, this can that you see right here is the original electrolytic filter capacitor. If you remember the schematic, there are a couple of fairly large capacitors with 150 volt ratings, and then a smaller capacitor with a 20 volt rating that is used to bypass the cathode of the output tube, the 50L6. And what they've done is they have bridged across this this can with some new capacitors. For example, this one is just connected to the original capacitor, and notice they left the original capacitor in the circuit. So I did a video on vintage electrolytics. And if you're interested in some of my reasons for what I'm about to say, you might want to watch that video. Now, I will confess that there are at least 3 and maybe probably a dozen schools of thought on what the best way to do this. Some people believe that the right way is to find a new old stock capacitor that's exactly the same as this one. Those can be very hard to find and extremely expensive when you do find them. Unless you're restoring a radio that I would call a museum quality radio, I wouldn't go that route. Now, if you were restoring this for use, say, in a museum, and you wanted it to operate and so on, well then yes, I'd go look for an exact replacement. But of course, a radio like this that were produced by the millions, they're not museum quality. So the next alternative is to cut these open, either by sawing them, as you may have seen me do in the SX62 restoration, or by removing them and opening them up from the bottom so that you can take the guts out and replace those with modern electrolytics. That's a second approach. I have done that, and it does produce a radio that is close to the original and it does work. There are all kinds of downsides, though, including the fact that you sometimes can't fit the new capacitors in the old space, although often the total size of the capacitors you're replacing, the volume is less. It's an inconvenient volume. In other words, you may wind up having to stack one capacitor on top of another, and you may not have room for the third capacitor inside the can and so on. So it's not necessarily, restuffing is not necessarily a great way to go either. What I have been doing for the last few years is leaving the original can in unless it's a dead short. And the reason is that these electrolytics will often reform, and if they don't, they usually, when they go dry, they go open. Well, if they're open, then this idea of bridging a new capacitor across them works fine. Now, some people criticize that method. Obviously, if the capacitor is leaking quite a bit and the leakage doesn't go away with reforming, then you don't have any choice. You've got to disconnect the old capacitor. You can't leave it in the circuit because it will draw too much current. But if the capacitor fails open, then you can bridge a new capacitor across it just as well. Well, some people are worried that maybe down the line that capacitor might short and take out the, say, the power transformer. Well, that's the reason I recommend that you put in the fuse that I mentioned earlier. I've already talked about, but I never did actually show you, the kind of cord that I like to use. Notice that this kind of cord has a wide spade here and a narrower spade here. Let me turn down here where you can see it a little better. A wide spade and a narrow spade. The wide spade is the neutral side. If you're using a modern outlet, that is one built within the last 30 or so years, this will only go in one way, and the side that has the wide spade will be the neutral. So what I do is I buy these cheap extension cords, and this particular one, I bought a bunch of them at Lowe's. It's called a Project Source. It cost $1.98 a piece, so I usually buy a half dozen or so of those so that I have a small stock. I'm not in the business of restoring old radios, but I do have quite a stock of them that I've accumulated over the years that I work on from time to time. So for $1.98, you can get a modern cord, and then of course what I do is just cut this end off and use it as a replacement cord. So let's also talk about the idea of, well, if you're going to leave the electrolytics in, maybe you might want to leave the papers in. I did a video on what is called a DIY capacitor tester. That is my number 135. It's based on the December 1959 article in Popular Electronics that you can find at the American Radio History website and download. This is the particular title page of that, and the circuit is down here. I won't try to hold it for you because it's probably better to just go to that website and get it. Here though is the schematic of one such. Now this is the one that comes out of Popular Electronics. I say one such because there were quite a few back in the day. In fact, this book, Practical TV Troubleshooting, is also available. It's the Gernsback number 102, and it's also available from the American Radio History website. And in it, there is also a capacitor leakage tester. These were useful back in the day because the idea there was you wanted to get a radio fixed and back out the door as quickly as possible. So you didn't want to go through and replace all the paper capacitors. You just wanted to find the one bad one and replace it. However, the biggest problem with leaky capacitors, not the electrolytic types, but the others, were actually in television sets. They upset sync circuits, and also the IF transformers of some TVs. The Admiral sets from the mid to late 50s were notorious for having leaky IF transformers, where the primary, the B plus on the primary, would leak through the insulation inside the transformer to the secondary and upset the bias on the next tube, usually in the IF. So leakage testers like this were very valuable back in the day. But if you take my advice and just replace all the paper capacitors, you don't need this kind of a tester. And it's my belief that you ought to at least try reforming electrolytic capacitors before you replace them. Often with even those that show a fair amount of leakage will sometimes reform fine if you bring the power up slowly, so that over a period of, and let it run for hours and then retest them, you may find that the electrolytics have reformed. Or they may have completely opened. If they've completely opened, then you can simply replace the capacitor or bridge across it. But the main thing is to have at least a system in mind. Now, if I were working on a museum quality radio, I would take the time to go out and try to find new old stock capacitors to replace it, especially for those things like this can that show from the top. Because if this were on display in a museum, a modern electrolytic, even if you could find a modern can, would just look out of place in a 1930s or 40s radio. So that is, those are a few of the things that I had mentioned but never followed up on in the earlier parts. Once again, I hope that this series has been useful to those of you that are interested or at least like to look at old radios, and that it will inspire a few of you to go out and try restoring old radios. Take your time, be patient, don't butcher the job. The better the radio, the more time and attention you ought to be willing to spend on it. So don't go out and buy an expensive, rare radio as your first project. Work up to it a little bit at a time. I suggest you might want to start with something like this, although it would actually be a little safer if you picked a radio with a power transformer so that it's isolated. But if you don't have a power transformer in the radio, what you can do is use an isolation transformer like this. But these are fairly expensive, at least relative to what we've spent so far. So far, all we've spent is a few dollars for some parts and a multimeter that cost $8. But if you're going to be working on radios long term, you should go out and get a variable isolation transformer or a variable transformer and an isolation transformer. As I point out in a video that I call the death difference, many of the variable transformers that are out there including those with the trade name Variac, are not isolation transformers. At any rate, I'd like you to be inspired, get into this field if it looks interesting, but most of all, be safe, have fun. So with that, I think I'm going to finally leave this series. I may come back to radio restoration in the future in something else, but the Frugal Repairman is going to move on to a few other things. And in the meantime, I wish you a nice day.